Here we are given this function t of t, which represents the temperature of a person during an illness in terms of degrees Fahrenheit. And we have to determine the interval when temperature was over 100 degree Fahrenheit. So first we are going to find out at what value of time, that is t, the temperature is exactly 100 degree Fahrenheit. So for that I'm going to put t of t equal to 0. I'm sorry, t of t equals 100 degree Fahrenheit, or if it is just numerical, I'll plug in 100 only for t of t and then find the corresponding t. So using this information, we can find the interval. So let's do this first. Let me replace t of t by 100. So therefore this becomes 100 equals 4t over t squared plus 1 plus 98.6. Now we subtract 98.6 from both sides. So therefore this becomes 100 minus of 98.6. This is equal to 40 over t squared plus 1. And we do the subtraction. 100 minus of 98.6. This is equal to 1.4. So we have 1.4 on the left side equals 40 over t squared plus 1. Now we can multiply, we can do the cross multiplication. So for that I consider this 1.4 as 1.4 over 1. So we do the cross multiplication like this. We multiply this 1 with 40 and this 1.4 with this quantity t squared plus 1 in the denominator. So therefore it becomes 1.4 times of t squared plus 1 equals 40 times of 1 is 40. Now we can simplify this. This gives 1.4 t squared plus 1.4 equals 40. Now let me subtract this 40 from both sides. So we will be getting 1.4 t squared negative 4t plus 1.4 equals 0. So this is basically a quadratic equation. We can use the formula to determine the value of t. So we have a equals 1.4 and this b equals negative 4 and c equals 1.4. Therefore the formula is negative b plus or minus square root of b squared minus 4ac over 2a. So let me use this formula to determine the value of t. So therefore t equals negative b, the b is negative 4, so it is negative of negative 4 plus or minus square root of b square, which is negative 4 quantity square, minus 4 times of a is 1.4 and c is 1.4 over 2a, which is 2 times of 1.4. Now we simplify this further. So this is negative of negative 4 is positive 4 plus minus. Let's evaluate the terms inside the square root. Negative 4 square is 16 minus 4 times of 1.4 times of 1.4. We plug this into the calculator. So I do 1.4 square times of 4, which is negative 7.84. So this is negative 7.84 over 2 times of 1.4 is 2.8. So this gives 4 plus minus 16 minus 7.84, which is equivalent to 8.16. We take the square root over 2.8. So this is, we can plug this into the calculator and determine the values of t. We will get two values of t. Once you plug this into the calculator, getting these values, that is 0.408 rounded to 3 decimal places and then 2.449. So these are the two values of time when the temperature is exactly 100 degree Fahrenheit. Now to answer the question, that is in what interval it is greater than 100 degree Fahrenheit. So let's plug this on the number line. Let's say this is t. So this is 0 and this 0.408 I'm putting here. It is 0.408 and 2.449 approximately over here. So we are having this interval, that is anything less than 0.0408, and between these two values of t, and greater than t is greater than 2.449. So to determine the exact interval, we have to utilize the given temperature function. So let me copy the temperature function, which is T of t equals 4t over t squared plus 1 plus 98.6. Now suppose if we consider the interval, the values less than 0.408, we can consider the value, one of the value as 0, and we plug this into this temperature function. So therefore this becomes 4 times of 0 divided by 0 squared plus 1 plus 98.6. This gives, this is 4 times of 0 is 0, and this is divided by 1 plus 98.6, which is 0 plus 98.6 is 98.6. So clearly this is not greater than 100. It is not greater than 100. So we can ignore this interval. So this interval is ignored. Now let's look at one of the values between the t values 0.408 and 2.449. Maybe we can consider the value 1, which lies between these two t values. So I'm going to plug in t equal to 1 into this equation. So we get t of 1 equals 4 times of 1 divided by 1 squared plus 1 plus 98.6. So this reduces to 4 divided by 1 squared is 1 plus 1 is 2 plus 98.6, and this gives 2 plus 98.6, and this is 102, sorry, this is 100.6, and this is clearly greater than 100. So we can say that it lies between the interval 0.408 and less than 2.449. Therefore, the answer to this question is the percent temperature was over 100 degree Fahrenheit between the interval 0.408 hours, 0.408 and 2.449. So this answers this question. That is the first choice. The choice in the first option is correct.